In this video, I'll be introducing Fourier Series. Let's start with the Maclaurin expansion of e to the x. And you see I kind of wrote it a little weird, in that I included x to the 0, which is 1, x to the 1, which is, and I wrote the exponent 1 on x. And also wrote the 1 coefficients. Okay, now the reasoning behind doing this is so that you can see that this is clearly just going to be some a0 times x to the 0 plus a1 times x to the 1 plus a2 times x to the 2 plus a3 times x to the 3. Right? Where they correspond right there. Okay? Now, what if instead of doing powers of x, I instead replaced all of those powers of x with trig functions? So what if I wanted to find e to the x in terms of a0 cosine of 0 times x plus a1 sine of 0 times x, on and on. Cosine of 1 times x, and plus b0 sine of 0 times x, plus b1 sine of 1 times x, and so on. What if I wanted to find the an's and the bn's for this? Right? Instead of powers of x, it's multiples of the trig functions, right? What if I wanted to find it? Well, it's something called Fourier Series, which is the topic of this video. So how do we find them, though? How do I find each of these coefficients? Well, first, let's look at a very specific integral. The integral from negative pi until pi of cosine nx times sine mx. Okay? What's the value of this integral going to be? Well, it's going to be 0 for a very specific reason. It's an odd function. Basically meaning if I input negative x, I'll get the negative value. Right? F of negative x equals negative f of x. Okay? It's an odd function. Basically meaning, if I were to graph it, now this isn't going to be an accurate graph, it might look something like that. Now remember, if the area is below the x-axis, you'll get negative area, and if the area is above the x-axis, you're going to get positive area. And remember, right there, all of these values are going to be the same, but negative. So this negative area, right here, is going to be negative pi. Right there is going to be pi. That negative area exactly cancels out with that positive area, and we get 0. We get 0. So now, what can I do about this? Well, first let's look at a couple more integrals, namely the integral from negative pi until pi of cosine nx times cosine mx. Now, this is actually going to be an even function, but so you're going to actually have to do calculations. But if you do those calculations, and I'll leave this as an exercise, you get 0 if the two things are not equal to each other, and pi if the two things are equal to each other. And then there's going to be another integral, very similar to that one, the integral from negative pi until pi of sine of nx times sine of mx. Alright? What's it going to be? 0 when m is not equal to n, pi when m is equal to n. Okay, so these are our three integrals. What is the point of doing this? Well, remember, we want to represent these as multiples of inside of the trig function. So suppose f of x is going to be the sum, I'll call it a n times cosine nx plus bn sine nx, right? Then, what if I multiply both sides by cosine mx, right? So, I get the sum of an cosine nx cosine mx, and then plus the sum of bn sine nx cosine mx, right? Okay, now let's integrate both sides in respect to x and evaluate from negative pi until pi. Integral negative pi until pi, right? Then integral negative pi right there. Okay, what will I get out of this? I'm going to move those integrals inside of the sum, so I get the sum of an integral negative pi until pi cosine nx cosine mx dx, and plus the sum of bn integral from negative pi until pi of sine nx cosine mx dx. Now, that right there is that one, except rearranged. That one right there is that one. So now, what is this value going to be? It's going to be 0 for all of them. That goes to 0, and this entire sum goes to 0. Okay, when is this not equal to 0? When n is equal to m. So, it's going to be a m, right? Because that's going to be the only non-zero terms when n is equal to m. A sub m times, and what's the value of the integral when m is equal to n? Pi. Would you look at that? Right there is equal to right there. Now you can do something similar for bn by multiplying it by sine of mx on both sides. But that doesn't end up helping. But that'll give you the coefficients on sine of nx, right? And so we get two formulas. We get a n equals 1 over pi times the integral from negative pi until pi of f of x times cosine nx dx, right? And bn is going to be equal to 1 over pi integral negative pi till pi f of x times sine nx, right? So, we're given these two formulas, and there's another one, a0, which is going to be actually 1 over 2 pi integral negative pi until pi f of x cosine nx dx. Okay? So, let's do an example. let's let f of x equal to x, right? Okay, let's figure out the Fourier series for f of x equals x. Okay, what's an going to be? An is going to be 1 over pi, integral negative pi, What's f of x? It's going to be x times cosine nx dx, right? This right here, the inside, is an odd function. Just as we discussed before, this integral will go to 0. Okay, now bn, on the other hand, it's going to be 1 over pi. It's going to be 1 over pi, integral from negative pi until pi, of x times sine of nx dx. Now this is not of the standard form, and what you end up getting is, and drumroll please, it's going to be negative 1 to the n plus 1 times 2 over n. And so I get that x roughly equals the sum from n equals 1 until infinity of 2 times negative 1 to the n plus 1 over n times sine of nx. That right there is how you represent the Fourier series for x. Now there's a problem with this. It's that sine of nx is periodic, so that means that the sum is going to be periodic, and x isn't periodic. So this is only going to be true on the interval negative pi to pi. And we're done.